Broadcasting live from SETI Alpha 6 in the Andromeda Galaxy, this is Mr. C.
Happy Aloha Tuesday to you. Wait a minute, Mr. C. It's not Happy Aloha time. Sure it is. Remember, I got a credit on Friday because I ended up not wearing an Aloha shirt. So, this is my credit day right here. So, that's why I have the Aloha shirt. Now, I have good news and I have bad news for you. So, what would you like first? Good news, bad news. So, bad news first? Okay. The bad news is the forecasted heavy snow in the high country, Flagstaff area, White Mountains, fizzled. Did not materialize. Let me tell you something. I have been watching meteorologists, those would be weather scientists, trying to forecast the weather for 60 plus years. And they often don't get it right. Why not? Why don't they get it right? Here's the reason. Yes, they're a whole lot better than they were when I first started paying attention, when I probably was 10 or 11 or 12. You were paying attention to the weather forecast then. What was wrong with you? So I'm teaching science. So I had an interest. I was curious way back then. So anyway, weather satellites have come in, and we have computers, and we have weather forecast modeling. They both help. They both increase the likelihood of getting the forecast right, but they often still don't. You know why? What's the reason? Because there are so many factors, aka variables, scientific method, that cause things to change last minute, and we don't know exactly why. So anyway, that's the bad news, the forecasted snow. So you skiers and snowboarders, sorry. We'll keep praying. Lord, bring us more wet systems from the north, from the west. Please give us a really great snow year, not for just snowboarding and skiing, but especially for snow melt and filling up those reservoirs. Okay, what's the good news? The good news is sort of no homework tonight. Now I'm going to give you time to work on homework in class. A nice, good chunk. If you work hard and you have accepted the greatness challenge to really, really step it up the next 5 weeks, on-time assignments, neat, complete work, really studying for quizzes and tests, all of that, you're going for greatness. So you will most likely be able to finish your homework in class. So I'm just saying, I'll give you time to finish in class. You should have enough time to get it done. So it'll be up to you. Okay, we've got to correct some homework, don't we? So correcting homework. So you know what? I'm going to get to that right after our break. That's what I'm going to get to that. So what's next? Well, I would like to ask you some questions on your white sheet. So I've got seven really important questions on genetics, key things that I want you to remember for a long, long time. Here we go. You ready? On your white sheet. Please don't look at anybody else's paper. This is just for you. Is this a pop quiz? No, it's not. But Mr. Gilbert is wandering around, and I want you all to participate. Remember, most of you were thinking, I'm going for greatness. All right, prove it now. Get a perfect on this. You can. Number 1, what do we call a characteristic we inherit? Like our height or our eye color, or abilities, any characteristic you inherit. Number 1 on your white sheet. Number 2, was the scientific study of inheritance. What is it called? There's a term for it. It's not an ology. You recall, not an ology. Yes, I know ology is often used at the end of a word, and it means study of, and it's an official scientific study of some area of science. Not the scientific study of inheritance or heredity. That was number 2. Number 3, what do we call a chunk of your 46 chromosomes that determine all of your traits? So what do we call a chunk, like a molecule, not a lot, a chunk of your chromosomes that influence a specific trait? Some from mom, some from dad. What's the term for it? Number 4, what do we call the form of a chunk of your chromosomes? It would be like this. It would be like having a chunk of DNA from your mom for, say, blue eyes, and a chunk of a chromosome for dark eyes, brown eyes. So a different flavor or form of number 3. What do you call it? Number 5. What do you call a characteristic that rules over another? So let's say you get certain chunks from your mom and certain from your dad. Dark usually rules over. So what is the kind of characteristic that rules over and doesn't let the other flavor express itself or show up? What do you call that? There's a name for it. Rules over. Number 5. Number 6. What do you call the flavor that you get that is hidden? You can't see it. For instance, you could have brown eyes, but it's possible you had another chunk of a chromosome that could have caused you to have blue eyes, and you can pass that on to your kids. So, what do you call the hidden characteristics? Number 6. Number 7. What do you call it when you have 2 different flavors of a chunk of DNA from a chromosome? What do you call that? That is number 7. And you know what? I'm not tricking you, but there's one more. So, number 8. Number 8. In number 7, you had 2 different flavors or 2 different kind of kinds of DNA for a characteristic. In number 8, what do you call it if you have the very same kind or flavor of DNA from both parents, like blue eyes from mom, blue-eyed characteristics from mom, blue-eyed from dad? What do you call that? That's number 8. Okay, red pens. Use your red pen. It's not a grade, but I'd like you to take out a red pen, use a red pen. So what do you call it? Here it is. Number 1, any character. Oops, you need a little more time. Get your red pen. All right, red pen's out. You were shooting for an 8, going for greatness. Number 1, any characteristic you inherit. That would be a trait. Number 2, the scientific study of inheritance. It's named for, gene is the root word. So what is it called? Genetics. That's number 2, genetics. Number 3, what do we call a chunk of a chromosome, a chunk of DNA, a chromosome that influences a certain trait? It influences. Could be the same or it could be different from mom and dad. So what do you call that? So that would be the form or flavor of a gene. What do you call that? That's called an allele. A-L-L-E-L-E. Allele. An allele. So you could have blue-eyed alleles from mom and brown-eyed alleles alleles from dad. Okay. The one that rules over, remember, dark usually rules over, dominates, or a dominant trait. So number 5, dominant. Number 6, a hidden one, might not have shown up in you, but it's still there. You can pass it on in your sperm or egg to your kids, and they can end up having that trait. So it's called a hidden trait or recessive. Recessive. The idea is it's recessed or it's back, so you can't see it. It doesn't show up. Recessive for number 6. Number 7, you've got 2 different flavors of a gene, like blue eyes and brown eyes. What's that called? That's a hybrid. Hybrid. So number 7, hybrid. And then the last one that I tacked on there at the end. So what do you call it when you have the same flavor from mom and dad? Like blue-eyed genes from mom or gene, blue-eyed from dad. So the same, or dark, or brown. What do you call it? That's purebred. Purebred. So a perfect time to break with Mr. Gilbert for a quick minute. He'll answer any questions, and I will see you in 60 seconds or so. So Mr. Gilbert's going to take it away, answer any questions, clarify anything, and then I'll be back. And as promised, I am back. Hey, you have worksheet 91F out, 91F. Here are your answers to 91F. You've got your red pen handy there. Hey, other pens, pencils away, please. Yep, stow those other pens or pencils. Thank you. Red only. Initials down below. Your promise to me and the Lord that you will grade this honestly. Kind of like a little pact, promise between you and he. All right, 91F, here are your answers. Number 1, a cow with a mix of red hairs and white hairs has the genotype, and then they tell you what it is. That would be an example of codominance. Number 1, codominance. It's where the alleles show up equally and express themselves equally. We'll get to that in just a little bit. Number 2 is acquired. It's an acquired trait. Having pierced ears is an example of an acquired trait. So, number 3, many alleles from mom and many from dad. What do you call that? Multiple alleles. Makes sense? Many, multiple alleles for number 3. Hey, each of these is worth a half a point. So it's wrong. Mark it wrong, please. Please be honest. Number 4, many genes from mom and many from dad to cause a trait. That would be polygenic. Poly, again, many, means many, like multi, prefix, it means many. Polygenic inheritance, number 4. Number 5, it's where neither alleles dominate. They end up, neither one expresses itself very strongly, so it's incomplete dominance for number 5. Incomplete dominance. The answer to number 6 is sex. Sex cells, sperm eggs. Number 7, C as in Charlie. C as in Charlie. Number 8, A as in alpha. Number 8, A, alpha. Number 9, D as in delta. And number 10, B as in bravo. So the last four for number 7, 8, 9, and 10. C, A, D, B. Number that you got right at the top, over 5. It's a 5-pointer. Each one's a half. Say if you missed 2, that would be 4 out of 5 because they're each worth a half, right? If you missed 3, that would be 3.5 out of 5. Okay. If you'll pass that. Oh, do you have your name on it? Name, date, period, upper right-hand corner. Make sure. Don't even think about turning it in. It'd cost you a point. So pass it into the center, please. Thank you, Mr. Gilbert, for picking all of those up. Appreciated. Okay, we have got to get rolling. Now, I'd like you to have at your disposal Lesson Summary 10, LS10. Get ready to write on it. And your next test will include information on LS10. There it is. Patterns of inheritance. You will note that I have circled some things, and you'll want to circle those as well. So, all right, here we go. So if you'll highlight that bold print sentence at the top in the top box, most traits are the result of complex patterns of inheritance. Now, you know when I showed you one of those basic Punnett squares and you've got tall and short. So tall rules over short in those pea plants. So in that first Punnett square, if you recall, was pure tall and pure short plants. They all the plants ended up being tall because the tallness trait dominated. So it was simple. It was tall or short, a simple pattern of inheritance. But most traits are not that simple. And here are examples. Now there's 4 examples that I want you to circle. And then I want you to come up with the example for it. You see those? And you see I have EX there by examples. All right, first. The very first one is incomplete dominance. So circle incomplete dominance, highlight it. Now the example they gave were flowers that had a chance to be red or white, called snapdragons. So you might want to circle snapdragons. And I put EX. See that I put EX right by those. What does that stand for? Example. That's the example. I'm just reminding myself. That's the example. You'll want to do that too. Okay? So those snapdragons, here's the way it works. It looks like they could have been white or they could have been red. Did they have genes for white and red petals? They did. What happened? Well, it's a complex pattern of genetics where neither of them express themselves over the other. It ends up being a tweener. So what did the flowers all end up being? They weren't red, they weren't white. It was sort of a tweener between the two. What was it? You got it, pink. It was pink. So they all look pink. So neither one dominates. Incomplete dominance. Now the next one, this is all in the top box, and these are bold print, codominance. Now you've got the prefix co in there. So they co or equally dominate. And notice, there we go. There's the example. You got your chickens. So they could have been, they had genes for black and white feathers. What did they end up being? They had both. So they had a parent that had black feathers, and the other parent had white feathers, and the genes cross, and what do you get? Both. They're black and white chickens. So that's codominance. They both show up It's not a tweener like incomplete dominance. Both traits show up equally, a co-dominant situation. Then, still in the top box, you've got polygenic inheritance. Now, poly means many. So above polygenic, I'm writing many there. Many. So polygenic inheritance. And then the example, there's a human trait that they use as an example. It's height. So this is caused by many genes. It's not just one gene from each parent that affects it, but many genes. So, and again, you want to circle height. See how I did that? Height for polygenic. So many genes. Did you get all that down? I'm trying to give you enough time. Okay. And then right up above it, you've got multiple genes. Many, many genes. So multiple genes. Many, many genes. Multiple. So I've circled it. Okay. So many genes. Multiple genes. So anyway, next quiz or test, all 4 of those babies you'll be responsible for. Okay? Now down below, have a look at down below. It talks about genes and environment and how they interact, how they kind of work together. And if you look at that bold print sentence, do you see it? Do you see it? There are certain factors in the environment. Are they genes? No. So environmental factors that can influence the way genes show up in an organism, in a living thing, like you. And there's 2 examples they have there, and I'd like you to circle them. One's a positive example that has the potential to work out really good. The other one is bad. And you'll see that in a minute. Okay, notice right underneath that bold sentence there, right there, we've got a nice example. So what does it say? You could have inherited a certain ability, but if you don't develop that ability, it's not going to express itself very well in you. And the example they give right there, but there's a whole bunch of other ones, is you could genetically be predisposed to be really good at music and, say, singing or playing a musical instrument. But if you don't practice and develop it, you could be better than the average person and have a good voice and all that. But you could have really been good if you would have developed that ability. You could have been really good. Now, I've got one of these. I was genetically predisposed to be a pretty good baseball player. A great baseball player? No, but a good, really good baseball player. So I was genetically predisposed to be physical kinetic, coordinated, and ever since I can remember I was a pretty coordinated kid. You know, I could run pretty good and like hand-eye coordination and catch things, and you know, it expressed itself in a lot of other ways. But would I automatically have been, say, a really good baseball pitcher? No. Now, I threw thousands of pitches in practice, and I became a pretty good baseball pitcher. Now, I was only like 5'9", so you know there was a physics limitation to how hard I could throw. So if I'd have been like 6'4", then I could have probably really had a lot more leverage and really throwing pretty hard. But God designed me this way. I'm happy with the genes that He gave me. In fact, I'm really happy with the genes that He gave me because He's happy with the way He designed me. Psalm 139, yeah. You form my inward parts. You weave me together in my mother's womb. So I praise You, for I am fearfully and wonderfully made. So, you know, long about 20, I figured out, hey, God made me this way. So, you know, I can really be pleased with it. And it ended up being so. Thank You, God. Thank You, Lord. So there's kind of the good example of environmental factors and being an influence. Okay? So the way genes are expressed. Now across the way on the other side of that bottom right box, there's a really bad example, a sad example. And I'm really thankful I didn't get caught up in this as a kid. And part of it was because I was an athlete. There's no way I would have been interested. No way. It was one of the worst things I could do to my body. Look what it says. Some environmental factors can change an organism's genes. See that? And then, for example, tobacco smoke and the chemicals in tobacco smoke and other pollutants can affect the genes that show up in a person's body cells. And in the case of smoking, cause lung cancer, which is often fatal. It's a very fatal kind of cancer, or at least will limit your future years or your future health. So it wasn't because of me. It was because God predisposed me to want to be athletic, that I had zero interest in trying to smoke. I actually had high school friends that, oh, just try one. Just try a cigarette. No way. There's no way I would. So I'm telling you right now, you know it is bad news. So anyone who says to you, oh, go ahead and try it. It'll be really cool. They don't really care about you that much. Do they have your best interests at heart? Not a chance. Do they love you? No. If they did, there's no way they'd suggest that you try something harmful to your body. And the bad news is there are addictive chemicals, nicotine, in cigarettes that can hook you very strongly, very quickly. So anyway, don't even think about trying it. So it just won't be a good thing. So again, this topic was, how do genes and the environment interact? They do interact. They do affect things. Skills that we've inherited genes to be good at, we've got to develop. And then negative things that we can put into our body that can change our genes and cause them to mutate and even cause tumors to grow, cancer to grow. So anyway, so there's all of that. And then I wanted to show you this. Check this out. Woo, gotta hurry. Okay, see this? I have a page for every class. See what it says at the top? HP. What's it stand for? Homework passes. And students that so far have not turned in homework assignments, you burned up your homework pass already. It's gone. You don't have one to use anymore. So, Mr. C, can you tell me if I've used it? Nope. It's your job to pay attention to whether you didn't turn an assignment in and you plan to use a homework pass on it. If you don't turn an assignment on time, I automatically am going to burn up your homework pass if you still got it available, and keep a list as to whether you used it or not. So look on RenWeb. So, and if it looks like you go, hey, I didn't turn that assignment in, but I still got credit for it. That was your homework pass. That's it. It's gone. Adios, amiga. So anyway, don't even think about asking me, did I use my homework pass, Mr. Chambers? Figure it out yourself. You're supposed to track that. So it's all yours to track. Now, I am looking already at the time, and 28 minutes have been burned up, so I've got to hustle with this. This goes in your LP, your lesson planner. So here it goes. There it is. Okay, in your lesson planner, you're going to have enough time to read these pages right now. 93 to 97, on there, number 6, see that? 93 to 97, read those pages. And then you've got a worksheet to work on for it. Now, when's this worksheet due? Mr. C, you said we don't have homework tonight. You don't. Or tomorrow night. Okay? But you've got to work on it in class for the remainder of the time that's available. It's not an option. Mr. Gilbert will Make sure that happens. So you're going to work on it until the end of the class. And if there's enough time, say if he's got 5 or 6 minutes now to work with, so he's going to make a call about a group that hasn't gone to the microscopes lately. And remember, don't touch the focus on the microscopes. Just turn the light on, take the cover, take off the plastic cover and turn the light on and have a look and make a little drawing in your journal, labeling what you looked at. You've got 5 or 6 minutes to do that now. The rest of you are spending time working on that homework assignment. 93 through 97, you're reading and highlighting, and then you're working on answering the questions with page numbers where you found the answer, and Mr. G is handing out those not lesson summaries, but worksheets right now. He probably has already completed that, and probably he's about ready to send some of you, 8 of you, back to the microscopes. So enjoy your Wednesday off on Veterans Day. Hey, you know what you might do is ask your parents, do we have any veterans in our family tree that fought in a past war for the freedoms of America? So it'd be a good thing to ask. Dinner table, meal together, just ask. And it would be good to think about them and just at least honor them with your thoughts. So on Veterans Day, which is why you have the day off tomorrow, turn it over to Mr. Gilbert now, and I'll see you back on Thursday. Adios.